My name is Josh Rauf, and this is Lab 4. The Introduction, Goals, and Principles. The purpose of this experiment is to examine the motion of an oscillating mass that is attached to a string and contrast it with the motion that the computer model predicts on GloScript. The principles we will use in this lab are kinetic energy, spring potential energy, gravitational potential energy, and the momentum principle. Here you are able to see that the experiment video. This video is put into Tracker, and the data is put into a CSV file that we export. In the bottom left, you can see the visual that the GloScript model creates that you will see the code for in a second. And in the top right, you can see the initial conditions that the ball is at, or that the system is. There we go. The GloScript code, notable changes in this first section would be the updating the ball mass, the ball position vector, the ball's velocity vector, and on in the right picture you can see the change to the spring. It's L naught as well, the spring constant, and the length of the relaxed spring represented by L naught, and the changing system energies to their respective formulas that are aforementioned on that I mentioned on the principal slide. That would be in the bottom section on the right picture. For this next section, notable things would be the force gravity on the ball, or the force gravity is just going to be a change for the vector in the y direction. Since gravity will only be acting in the y direction. The F spring to just being changed to the spring formula. F net being F spring minus F grav, and the ball and its position update formulas being put there respectively. That'd be the third section, or the fourth section. And at the bottom you can see the spring update being changed to the ball position minus the spring's position, as long as with L hat. For this last section, we change all the formulas to their respective ones, and if you notice, all the deltas respectively go from their K final minus their K initial. For the data, most notable, we want to be looking at the delta E. The other lines, the most notably, we want to be looking at the orange line straight through the middle, which is the total energy, and we want to look at that because this constant energy shows that the energy stays the same throughout the entire duration of the experiment and the model, because energy is not created nor destroyed. It's only converted into other forms, and that is why you see such equal distribution of things happening in the other colors, is because when energy is converted, it is converted proportionally into something else. It's for this graph, the blue line is the model position and the red is the experiment position. You might be wondering why they're different. The experiment position doesn't quite line up with the blue model position because of likely human error, like drag and other small things that cause energy loss that we might not be able to fix easily. What does this mean? Aforementioned, the energy principle shown by the orange line, this does satisfy it. because the energies change consistently or are converted consistently. And for the second point of what does it mean, the periods of oscillation for x and y are 1.638 and 1.519 respectively. And all that means is that we are going to get two different spring constant for each direction. Thank you.